movement of water. First, we want to look at the term hypertonic. A hypertonic solution is a solution with a higher concentration of solutes in comparison to the cell. So that means that the environment that the cell finds itself in has a greater amount of solutes than the cell does. And so we see that here in this picture. These are the solute molecules, and there are a lot more of them outside the cell than there are inside the cell. That's going to cause a net movement of water out of the cell. Water will always move to the area that is hypertonic. The other thing we have to understand about these environments is how they affect animal cells and plant cells. So if we look here at an animal cell, when an animal cell is placed in a hypertonic solution, there'll be a net movement of water out of the cell. That's because there's more solutes outside the cell, and so water wants to go to the area with a higher solute concentration. And so this will cause the animal cell to shrivel. In a plant cell, it's a little bit different. The plant will still lose water to the environment. There'll be a net movement of water out of the cell. But because the cell has that cell membrane, the cell wall doesn't really change shape, but the plasma membrane, the cell membrane inside the cell, will shrink and shrivel up to the middle of the cell because the cell is losing water. So the plant cell shrivels also, but it looks a little bit different because the plant cell has that cell wall. So again, in a hypertonic solution, there's more solutes outside the cell than inside the cell. And so water will move out to the area with higher solute concentration. In a hypotonic solution, this is a solution with a lower concentration of solutes in comparison to the cell. So here in this picture, we should notice that there are more solutes inside the cell compared to outside the cell. This time, water wants to move inward. Again, water is always moving to the area of higher solute concentration. So water will move into the cell. Well, this affects plant and animal cells differently. For animal cells, this will cause the cell to lyse or burst. So there's so much water coming in, and because animal cells don't have that rigid cell wall, there's nothing to keep that cell from bursting if it takes up too much water. In a plant cell, however, because there is that cell wall, and a plant cell can take up water, and will take up water to the point that it actually is kind of swollen, that the plasma membrane, the cell membrane, pushes up against the cell wall, and we refer to plant cells in this situation as turgid. This is actually a plant cell's happy place, so to speak. This would be considered their normal. This is the way a plant cell normally wants to be. It wants to be in a hypotonic environment and to be able to hold as much water as possible. An animal cell, on the other hand, could burst in a hypotonic solution. In an isotonic solution, this is a solution that has the same concentration of solutes as the cell. So there's still movement of water into and out of the cell, but the movement of the water is at equal rates, both in and out of the cell. So notice that for an animal cell, this is considered the normal. This is an animal cell's happy place, is to be in an isotonic solution. For a plant cell, because the plant cell isn't able to take up as much water as it could possibly hold, this is not the ideal situation for a plant cell. And in fact, plants will start to wilt or become flaccid if they are placed in an isotonic solution. Okay, the last type of passive transport that we need to talk about is facilitated diffusion. So notice that it is a type of passive transport. Diffusion is in the name. It does not require energy to move the molecules because the molecules are moving down their concentration gradient. So how this is different from simple diffusion is the fact that in order to move these molecules across the membrane, it requires membrane proteins to move them. So simple diffusion, the molecules can just pass right through the phospholipid bilayer, either into the cell or out of the cell. With facilitated diffusion, it now requires the use of a protein in order to move those molecules. So this purple structure here is a membrane protein. And so notice that these molecules are still moving from where they're in high concentration to where they're in low concentration. That's why it's diffusion. But it's facilitated diffusion because the protein is helping to facilitate or aid the movement of these molecules across the membrane. This is a nice picture because it kind of puts all the different types of passive transport that we've talked about together in one spot. So this helps to remind us that osmosis is specifically the movement of water across the membrane from where it's in high concentration to where it's in low concentration. So notice that water will always move to the hypertonic area, to the area with greater solute concentration.